Okay, normal distribution. Yesterday you learned about density curves, and you even learned about a uniform distribution. And today we're going to move on to something called a normal distribution. Nolan.
Yeah.
Okay, you're focused on me now. Density curve, what is it? Remember, I'm asking Nolan, but I'm asking all of you the same question right now. Density curve.
Well, it's the area. It's the curve that goes over like histogram.
Good. That's the first thing I want you to remember. All these curves that we draw came from a histogram. And the second thing?
The area underneath it equals 1.
Perfect. Or
100%.
100%. Okay? That's what we learned yesterday. That's what a density curve is. All the curves we draw from now on. Remember, the histogram we drew yesterday, if we took the area was nowhere near 1, but we did some crazy mathematical stuff, and the area became 1, so all the curves we draw from now on, just remember that the area underneath it is always going to be 1. So today we're going to learn about this thing called a normal distribution. Maybe some of you have heard of grading on a curve. You've heard of that before. When you go to college, you're going to see a lot of that. I had somebody third period say, is this a bell curve? Yes, it's exactly what we're talking about, a bell-shaped curve. And what it means. Now, why it's important is we keep finding in real life that this shape comes up when we draw histograms, when we draw a curve over, the shape comes up over and over again. Like, for example, when you take tests, or SAT tests, or whatever, when all the grades come back and they make a histogram, you know, most of the students did kind of in the middle, you know, C range. Some students did really well, some students didn't do really well, and this shape comes up over and over and over again. It also comes up in gambling. You're going to learn a lot about gambling in this class. You're going to go home to your parents, what you learned today. I learned about gambling. Don't say that, but you're going to learn the bad side of gambling, trust me. Casinos understand this bell-shaped curve. They understand that's why they're going to take your money. Okay, that's something you're going to learn about too. So it happens over and over and over again. So how do you know if you created a histogram and you've actually got a normal distribution? Now, these are the scores from last year, period 3's test. Okay, so this was their scores. I'm going to show you their graph, their histogram. Now, I'm going to show you what to type in a second. No, you don't have to put those in your calculator. All right, I got to match this thing up here perfect. Your number line on the bottom. Those are your shapes. But what I do want you to copy down is we're gonna draw our density curve here. And I'm not real good at this. I'll do the best I can, but so remember, it came from a histogram. I don't care about the histogram anymore. This is what I'm doing. Okay, so this was the density curve from period 3's test scores last year. All right, what am I looking for? A normal distribution is 3 things. Number 1, it's going to be symmetrical. What do you guys think? Shake your head no. What do you think? Yeah, I definitely, it's not perfectly symmetrical, right? It's symmetrical. I put a mirror down the middle, looks exactly the same. It's not horrible, but I do definitely see a little bit of a skew left there. Okay. Also needs to be unimodal. How about this guy for unimodal? Yeah, absolutely, definitely unimodal. And then the last thing is it has to have this thing called medium tails. And what that means is visually, okay, so I've got most of the scores in the middle, and then I've got lesser and less that go out to be really, really good scores, and lesser that really go out to be bad scores. All right, visually, if we're trying to see if we have a normal distribution or not, the book gives you a little hint on this medium tails thing. So if you open up your book to page 86. And it defines this thing called inflection points. Now, you calculus freaks probably know what you're talking about, this inflection point stuff. I'm not even sure I understand what inflection points are, but basically they are when your curve starts going from this way to this way. Okay, it's kind of changing directions at that spot there. Okay, and generally you'll find them if you look at your picture on 86. Those are where you'll generally find the inflection points. So, do we have medium tails or not? Well, these inflection points are supposed to kind of be happening about 1 standard deviation from the mean in both directions. So 1 standard deviation above the mean, I should kind of be seeing this inflection point, and 1 standard deviation below the mean, I should be finding this inflection point. So what are they talking about? Here's my mean, and there's what a standard deviation is. So let's take a look. What is 1 standard deviation above the mean? Well, the mean's right about here. 65.5 is right about here. Okay, so that's where the mean is. All right, so I've got 65.5 plus a standard deviation. That takes me to what? 76.2. So let's go find 76.2. That's right about here. Let's look up. Would you call that an inflection point as you see it on page 86? Did you see it going, changing directions? I don't think so. Let's try the other side. Let's go 1 standard deviation below the mean. So I've got 65.5 minus 1 whole standard deviation. So we got 0.8, 4, 5, 54.8. Let's go find 54.8. That's right about here. What do you think about that one? Comparing it to the picture that you see. I think that's closer. Okay? So, and if you look at the picture, this kind of looks a little bit more bell-shaped, normal. And this guy just kind of comes down a little too fast. Okay, maybe I'd have liked to see a few more scores out here coming this way to make it perfectly normal. Okay? So, just as a visual inspection, let's go through it. Is this thing symmetrical? Not so much. Unimodal? Yeah. And does it have medium tails? Kinda. Okay? Now, a visual inspection is one thing. We can kind of maybe, if we see some crazy binomial thing, we know it's not normal. Okay? But we need to do a better inspection to see if our data is in fact normal or not. Now we're going to learn 3 or 4 tests. I'm going to give you one today. Okay, this is not one you'll generally use, but this is kind of a way to see if your data that you have is distributed normally. And it's called 68, 95, 99.7 rule. When I was you, this was called Chebyshev's theorem. I'm glad they got away from that name. This name's actually better. If you can remember this name, you can kind of remember what's going on. Here's what this rule is saying. If the data that you have is normally distributed, then right about 68% of the scores will be within 1 standard deviation of the mean. So if this data was perfectly normally distributed, about 68% of these, there's 33 total scores, about 68% of these would be within a range of 1 standard deviation of the mean. Now, what is the range of 1 standard deviation of the mean? What is the range of 1 standard deviation of the mean?
2 standard deviations.
Okay, what is that range going to be?
It's the mean plus the standard deviation.
Right.
Plus.
So for this problem.
So that would be 65.5 plus 10.7. And then you also add 65.5.
So did we already do that?
10.7.
Did we already do that?
Yeah.
Yeah, so there it is.
There,
Yeah, there it is. This is the interval 54.8 to 76.2. What this theorem says is if this data was truly normally distributed, about 68% of these would be in that range. Go find out what percent of those are in that range. Go. What percent of that data is in fact within 1 standard deviation of the mean? actually doing a mathematical inspection of this data. If these three things hold, then this data, we can say, is normally distributed. And 68%, that means most of the data is right around the middle. All right, Haley, what'd you come up with?
69.7.
No, I don't think so. What'd you get?
51.5. 75.
How many numbers did you get in that range? Out of curiosity.
17.
75.
There's more than that, isn't there? How many are there? 25. There's actually 25 numbers in here. We're looking for all the numbers we can find that are in this range. So you must have missed a few, right? There's actually 25 of them. So 25 divided by 33, did you get around 75%?
Yeah, 75.
Okay, so actually, with our data, actually 75% of the scores were within one standard deviation of the mean. What does that represent? It means the data's too bunched up. There's too many scores inside of here. And that kind of makes sense. Remember, I wanted this thing to kind of go out and have some more scores out here instead of come down straight like that? We've got too many scores in there. 75%. This is supposed to be 68% of the scores if it's a perfect normal distribution. And we kind of saw this visually. It wasn't matching up. But now, mathematically, we can see we've got too many scores in there. Well, let's try the second one. The 68, 95, 99.7 rule says that 95% of these scores should be within 2 standard deviations from the mean. I want you to go figure this out. First, find your interval. You got some work to do there. What's your interval that's going to be 2 standard deviations from the mean? And then what percentage of those scores are in that interval? All right, talk to me, Mason. What'd you do first?
Multiply standard deviation by 2.
Yeah, I got to go 2 of these guys. I've got to go 2 standard deviations both ways. Okay, so what is it, like a million? 21.4?
Yep.
So what'd you do with the 21.4?
Subtracted it from the mean and added it.
All right, so we get 0.1 for 44.1.
Yes.
Is that right? And then you say you added it to the mean as well?
Yep.
86.9?
Yep.
So the interval you all should have been looking for goes from 44.1 to 86.9. Let's take a look in the picture with that. Let's create that interval now. So we're supposed to go now from 44.1, which is about here. That's 2 standard deviations from the mean. And then 86.9 is about there. We're trying to find out the percentage that's in here. Did you get a number yet on this?
Yeah, it's 96.9%.
About 97% of them, right? 97% of this data is within 2 standard deviations of the mean. So here, not so bad. It's never going to be perfect, but if you're within a percent or 2, that's not too bad. So as we got a little bit further out, okay, it got closer to where it was supposed to be. All right, 3 standard deviations from the mean, they're all supposed to be in there. Go create your interval and see if, in fact, all of the data, all of those test scores, are within 3 standard deviations of the mean. All right, Kyle, what's my new interval?
33.4 to 97.6.
Is that right? 97.6? We took the 10.7, multiplied it by 3. What is that, 32? I add 32.1, subtract 32.1 to get my interval. Was about 99.7% of the data within that interval. In fact, all 100% were. So, I think we're all in agreement, both visually and using our 68, 95, 99.7% rule. This wasn't a perfect normal distribution, but it was pretty darn close. And it was real data. This was really the test scores. And if we did it on your test, we'd get very similar results. Okay, so would I say this is a perfect normal distribution? No. Would I say it's closely represented by a normal distribution? Okay, Is it roughly a normal distribution? Sure. These are three picture views of the 68, 95, 99.7% rule. Okay? All right. Ready to apply this? See how it works? All right, let's pretend that this data was a perfect normal distribution. Okay, so I'm just going to pretend for a second that this is going to hold, okay? What percent of these test scores should I expect to be above 76.2? If these were a perfect normal distribution, what percent of the test scores should I expect to be above 76.2? Everybody think about that a second. Write down what you think that answer is. What percent of these test scores do I expect to be above 76.2? Raise your hand if you think you've got it. Okay, think about it. All right, I'll give you first shot at it. Kyle.
16%.
Yes, darn it. Yes, the answer is 16%. Is that what you had? What you have? 32? 12. You got that. All right. Here's the deal. You're going to do a bunch of problems like this tonight. You are going to draw a bunch of pictures. You guys did a great job, by the way. Other classes, not so much. I can see why period 6 is where they are. Okay? All those pictures you drew, okay, that's exactly what you're going to do tonight. And they have to look exactly like I want them to look. So this is how, for all these problems tonight, every single one, this is what I'm going to want to see. You're going to draw your normal curve. Remember, I told you this data was normal. You're going to identify the mean. You're going to show me what specific point I'm looking for, and you're going to shade that region. Then you're going to use your knowledge here, hopefully, to figure out what that answer is. So, for example, this is what I want to see on this problem. Nothing different. We draw the normal curve. We identify the mean. The mean was 65.5. I wanted to know the percent of the scores that was above 76.2. Now, I picked this number on purpose. So this is a number line, remember. Don't forget this is a number line. So where is 76.2? It's over here someplace. I draw a line up and I shade the region that I'm interested in. Now remember, this whole region is what percent? 100%, okay? And I want to know the percent of the scores that were above 76.2. So that's what needs to be shaded. Write that down. That's what you're going to be drawing about 50 times tonight. All right, Kyle, how in the world did you figure out that that was 16%?
Since everything is 68%.
So which picture are we dealing with here, first of all?
The top one.
Yeah, wasn't it one standard deviation from the mean? Wasn't that what 76% was? Okay, go on.
And then you subtract that from 100.
Okay, so I know 68% is in the middle here, right? Underneath the whole thing is 100%. Go on.
So that gives you 32.
Okay.
And then you divide that in half because you know you're only dealing with half of that.
Okay, so he says I can just divide this in half, so they both must be 16%. Now, the reason he can divide it in half, don't forget what a normal distribution is. Isn't a normal distribution symmetrical? So it means it looks exactly the same on both sides. Okay? So, tonight, you would then write a sentence. So here's what I'm looking for tonight. You draw your picture. The percent of scores above 76.2 is 16%. Okay, I don't want the percentage is 16%. I want you to write it up as part of the problem. Yes.
Are they going to have us say like what if the scores are above 78?
No. Well, I'm going to become more situations here in a second. Give me those three intervals again. What was the other one? 44.12.
86.9.
And then what was this one?
33.4 to 97.6.
All right, let me give you how a different question might be asked of you. Now this time, first thing you do, before you do anything else, you draw the picture. Don't think about it, just get that picture drawn, take a step back, take a look at that picture. Same situation, okay? This is the situation, and we have a perfectly normal curve. If you got a score of 44.1, what was your percentile? If you got a score of 44.1, draw a picture, don't think! You got a score of 44.1. What was your percentile? Well, obviously, if you don't remember what percentile is, you better be looking that up. Then you got to figure out what does percentile look like on this graph. Okay, I'm not feeling very good right now. I haven't seen one right picture yet. Oh my goodness. Oh my goodness. Getting a little worried. Eric! What's percentile mean?
A percentile is a percent of data that
Okay, what does it really mean? I want you to read me a definition. What does it mean? If I got a score of 44.1, what does that mean in English?
That means you're at
Come on now! Now I'm asking Eric, I'm asking everybody. Better be looking this up, better be able to explain it to me. If you got a score of 44.1, what does percentile mean?
were you at 41st percentile?
What does it mean? You don't give me a definition of percentile if I say a percentile.
That you
Yes!
out
Yes!
all the people that had that score or lower.
Yeah, it's the percentage of people you beat. What percentage of people did you beat? That's correct. All right, so what does this picture look like? Think it through. So I draw my normal curve. I identify the mean. Nothing changes here. Okay, I'm interested in 44.1. This is a number line, so 44.1 is over here someplace. Now, where do I shade that represents percentile?
Shade to the left.
Yes, this is the percent of people I beat. People that got scores over here. All right. Casey, which picture are we on here? Which one of the 68, 95, 99.7 rule am I dealing with in this particular problem? Yeah, why? Why? You're right, why?
Because you're using the middle.
What's special about 44.1? What is 44.1 that put us in this middle picture?
It's 2 times standard deviation.
Yes, 2 standard deviations below the mean. And in fact, tonight, if you want to get fancy, we're going to learn this tomorrow. This is actually, you can put like a -2 here. You don't have to. You don't have to have that. But that just kind of reminds you had to go 2 standard deviations below the mean. If it was above the mean, you put a +2. All right, now help me out. Based on that picture, what percent is going to be over there in the left-hand corner?
2.5.
Yes, very good. How'd you get it?
They're symmetrical, so there's 5% left over.
Very good. Symmetrical, there's 95% in the middle. He said there's 5% left over. That must mean there's 2.5% over there. So, that means that a score of 44.1, you only beat 2.5% of the students. You only beat 2.5% of these scores. Yes?
So we're just assuming a perfect bell curve?
Yeah, I just said that. I assume this is a normal curve. In fact, this is how they're going to do it in your book, okay? They're going to give you this notation. It's going to be an n and let's say 60, 8. When they tell you that, they're saying, okay, the data that you have is perfectly normal. Okay? Now the next number you see, that's going to be the mean of all of those scores. Okay, ours was 65.5, but if they tell you 60, that means all of these scores, the mean of them is 60. And the second number you see is going to be standard deviation. So that's telling you what the standard deviation, the typical difference from the mean, all of these scores were. All right. Yeah.
For taking the difference of what's left and dividing it by 2, is that going to be relevant if it's not the standard bell curve?
Well, this is all the problems that we're going to be doing in this chapter. From now, they'll assume a normal distribution to start. You're right. If it looks like this,
Yeah.
it can't be exact like that. Remember, we have a more percentage over here, and it's not 68 in the middle and all that stuff. But all the problems they'll give you tonight will be based on this information. Yeah.
Do you want us to write out the addition and subtraction work?
I want you to show me how you got the intervals. If they ask you to go get intervals, sometimes they'll ask a question like this. Here's your situation. Okay. What score would be the 84th percentile? What score on the test would put you in the 84th percentile? Why do I not see anybody drawing a picture? That's the first thing you do! Draw a picture of this situation. Don't think, just draw it. Try to get it on paper. You can step back from it and say, oh, I got it. I know what's going on. I'm looking for what score, what test score. Now we're over here now, right? The mean is 60, standard deviation is 8. What test score would put you in the 84th percentile? So first got to try to draw a picture of that situation. What is that? What is that situation? All right, Chris, what's your picture look like? This is got a couple of little different things going on here. I'm interested to see what you did. Okay, so you've got your normal curve, and then what you put on next?
The mean.
Which is 60, right, in this case? And then what'd you do?
I did the standard deviation from the mean.
Okay, I don't want that. I don't want any, like tomorrow, I don't want to see anything like this at all. Okay, I don't want to see, I just want to see, so I'm supposed to be finding the 84th percentile, and it's a number I don't know. So let's start putting stuff on here that I do know. So what else can I put on here?
Intervals by the standard deviation, like 68 and then 76.
Okay, I don't want a 76 here. Okay, what I want, so you haven't solved the problem yet. I just want you to draw the situation. Here's what I mean. 84th percentile. Where's my line going to be? Is it going to be over here if it's the 84th percentile? Is it going to be over here?
Right.
It's going to be the right, right? Because this is 50% here, right? Now, how do I know that's 50%? Didn't we learn yesterday that the median was broken into 50% on this side and 50% on this side? Remember the median's the 50th percentile? Well, what do you know about the mean and the median if the data is symmetrical? The same. Okay, so now I know 50% here and 50% here. So here's what I want you to do here. I know that it's going to be over here someplace, and this is going to be 84%. Okay, because that was a part of the problem. And then I know what you're just working ahead here. What I want you to do right now is put an X there. That's what I'm looking for. Okay, when I say put the relevant information that they give you on your picture, in this case, this is what they've given us. I'm going to shade it a little bit, that's fine. Now, go ahead. What'd you do now?
Next,
Which picture are you working off of, do you think?
the 95%.
Working off of this one, okay? How'd you work off this one? This is 2 standard deviations away, so how'd you work off this one? Remember, this is 84%.
Because I know if there's 84% shaded, there's 16% not shaded.
Correct, but all 16's over here, right?
Right.
Okay.
So 16% would mean 2 standard deviations away from the mean. Yeah.
Let's take a look at these pictures again. Okay, here's 68%, right? So what's left over?
30. Oh, yeah.
There it is,
Okay.
right?
Okay.
There's the 16%. What's in that guy?
That's 2%.
2.5%, right? So you just you're matching which one works tonight. So I agree. So it looks like it's not 2 standard deviations away, it's 1 standard deviation away. So what must this score be?
68.
Correct. Very good. He took the mean and he added 1 standard deviation. Okay, so that score is 68. So your write-up is a score of 68, puts you in the 84th percentile. You got a weird look, you okay?
Yeah, if it's 68%, oh, then you add the...
Look what happened. Look what I did. When I said 84th percentile, I did this 68, but what's over here?
The rest.
the other 16, right? I added the 64 and the 16. That's how I got the 84th percentile. So you're getting a little puzzle you've got tonight to do? Okay, so on each and every problem, draw a picture that represents what they're talking about. Okay, and on the picture you're going to have the mean. Sometimes they give you this number, put it there, you're looking for the percentage. Sometimes they give you the percentage, you're looking for the number. But draw a picture that represents that problem, okay, and then it'll be one of those 3 rules tonight. Now, starting tomorrow or the next day, I can give you any situation, and you'll be able to figure out the percentage. But for right now, it'll just be these 1, 2, or 3 standard deviations from the mean. Okay? A lot of stuff. Okay? We learned about what a normal distribution is, what it looks like, a way we can kind of calculate to see if we have a normal distribution or not. But if we do, these 3 situations hold, and we can answer a lot of real-world questions just because we know the data is normal. Okay?